Hello, guys. Welcome back. It's rainy today, a little overcast, but should be nice later on today. Great day to learn about areas of circles. Don't worry, we're not going to do this. We don't need to go back there. We are going to learn about circles, though, but just the areas. Here we go. Let's do this. So, as noted in Google Classroom, if you want to know where these formulas come from, watch those two videos. They explain it way better than I ever possibly could. But from those videos, we know that the circumference is 2 pi r, or you could also say that it's pi d. And the area of a circle is pi r squared. Now, I must have the wrong version of notes because I have in the spiral that there's one more thing. Sector of a circle. Sorry about that. And this really isn't too bad. You got to just think about it as a circle's 360 degrees. So we want to figure out what angle or like kind of what percentage of 360 we're using, and then just times it by the area. Because if you're looking at a sector, you don't want the whole thing. You just want part of it. You want however many degrees of the 360. So let's just get to the notes. Let's find the area of this picture. Well, I think this is easiest if we cut it into shapes that we know. Well, we spent last time talking about triangles. So there's this nice triangle and rectangles. So we've got these two shapes here, but we've got to figure out what the missing parts are. So it is telling me the whole thing here is 31, and that this part is 22. Well, then by some simple subtraction, we know this has to be 9. Okay, so we've got this triangle here. Oh, well, that's nice. It's a right triangle. That's 15 by 9 by, we don't know. But then we also have this red rectangle, and we know that it's 22 here and here, but we don't know its height. But if we look at this, the height is x. It's going to be the same thing. Then we have this, what we call semicircle. Well, we don't have a formula for the area of a semicircle, but that's just half of the area of a circle. But again, we're not going to be able to solve this unless we know what r is. Well, this dotted thing here is also x, if you didn't realize. And then later, we're going to want to use the radius. So that's going to be half of x, because x is our diameter. So let's solve this thing. We've got 15 squared equals 9 squared plus x squared. So that's going to be 225, 81, x squared. When we subtract 81, 144, x squared, take the square root, and x is 12. So now we can replace all of these x's with 12. So we've got 12, 12, 12, and then our radius is 12 divided by 2, so 6. All right. Area equals base times height divided by 2, so that's 54. Centimeters squared. Don't forget the units. The area of a rectangle is base times height, but not divided by 2. So let's see. 22 times 12, 264. Centimeters squared. And then finally, the new part. Well, let's see. the area of a circle is pi r squared. So that's going to be pi times 6 squared, or 36 pi, but we only want half, right? We don't want this part. That's not in our shape. So we're going to have to divide this by 2. Now, on everything that we're doing in this unit, we want to approximate pi. There's a button on your calculator for it. Also, if you just Google like 18 pi, it should give you an approximation. So let's see, I'm going to go ahead and go to Google, type in 18 pi. I'm going to use the calculator, and it looks like it's about 56.5. You could also use that pi is approximately 3.14, which is why we celebrated on March 14th, Pi Day. So there's the areas of each shape. We're just going to add them together. So we've got 54 plus 264 plus 56.5, giving us an area of 374.5 centimeters squared. So the area of this shape is 374.5 centimeters squared. Cool. Kind of tough, but we got it. All right, so on here, determine how much paint is needed to paint the darkest sections. Well, it's kind of tough to tell here, but there's some notes in your spiral. I think I'm using the wrong version, but that's okay. We'll figure this out. We want to know this. So this circle here in the middle, I'm going to blow it up so it's a little bit bigger. Looks like it's telling us this is 6, but we know that we really only care about the radius of 3. Then we have this going on here. But we only care about this part. It tells us that this is 12, and that from here to here is 19. Now we have 2 of those. So whatever answer we get, we're going to multiply by 2. Well, this is actually a composite shape. It's 2 things. It's a rectangle that's 19 by 12, and a circle that has a diameter of 12 or a radius of 6. Now we've got to be careful here because, again, we're only caring about part of it being painted. So really, we're going to have to figure this out and then subtract this part. So let's do that. This one's not too bad. This is pi r squared, so 9 pi. Again, go to Google, type in 9 pi, 9 pi, and I get that this is 28.3. Then here, it's a rectangle, so base times height, 19 times 12, gives us 288. Or sorry, 228. This is a circle, so we have pi r squared, or 36 pi, 113.1. But we really don't care about all that. We only care about half of that because we only need to eliminate this half because that's not getting painted. So we're going to divide that by 2. That's going to give us 56.5. All right. So now the fun part. We have 2 of each of these. So we need to calculate these 2 areas, which is going to be 228 minus 56.5. That 56.5 is this part that we don't want, and that 228 is the rest of the shape. but we have 2 of those, right? 1, 2. So we're going to take this times 2. That'll give us the area of the free throw lines. And then we just need to add it to our 28.3. Okay, so 228 minus 56.5. Then we're going to take that times 2. So that gives us a nice 343 for the free throw lines. And then for our inner circle, that 28.3, add it all together. And we get 371.3 square feet of paint. Whew. That's a lot of work. All right, the last one we're going to look at, and then depending on time, maybe kind of look through the ones that are there for practice. But otherwise, just take the notes, be ready to ask lots of questions. Now again, we're looking at some different shapes. So let's break it into parts that we know. I've got this nice triangle here. That's 5.7 and 4 and unknown. We've got this nice rectangle here that's 4 by 7. And then we've got this semicircle again, but it tells us the radius that's 4. Now again, remember, we don't have a formula for the semicircle. So we need to find the area and then divide by 2, because we only want half. We don't want any of this. That's not in our shape. Okay, well, this is a right triangle, so here we go. Pythagorean theorem. 5.7 squared equals 4 squared plus x squared. Grab your calculator. 5.7 squared. 32.49 equals 16 plus x squared minus 16. All right, 16.49 equals x squared. Then we're going to take the square root of that. And we get 4.06. So maybe like 4.1. Okay, so cool. We have everything we need to now solve. A triangle is base times height divided by 2. Base times height divided by 2. And I'm getting an area of 8.2. All right, so we figured out that area. This one's not bad. It's just a rectangle. Base times height. So 28. Cool. And then lastly, pi r squared. So 16 pi. So I'm going to go to my calculator, type in 16 pi, 50.3. But remember, we only want half. And then depending on how you rounded, you either got 25.2 or 25.1. I rounded up to 50.3 divided by 2. And I got 25.2. All right, so we found each of these areas, but it wants the total area, so we're just going to add all of those together. 8.2 plus 28 plus 25.2 to give us an area of 61.4 square feet. Okay. Well, I hope this was helpful. I know you guys are going to have questions, so please take the notes. Please write questions in the notes. Let me know what questions you have. I'll see you next time, so make sure to hit like and subscribe. and click the bell for notifications.